Three. Hi everyone, can you hear me? Okay, so let's start now. So today we are going to see a few of the protocols which are RARP, BOOTP and DHCP. Okay, so let me begin. So suppose your computer is booted and then at that time you will be needing your own IP address, which means like currently you do not have your own IP address because your computer is just booted, and let's suppose that you want to connect that to internet. Then you will be needing following things, which is your own IP address, your subnet mask. In this will tell you that what in which network you actually lie on, right? I mean, what are the number of hosts and all. So basically this subnet mask is important just to tell you that you are inside which network. So that's why you will be needing subnet mask. IP address of default gateway, which means that you will be needing this to know that if you want to forward some packet, then to which router or to which default gateway you should be forwarding if this is not matching to none of the entry in the routing table. And if you want to type something which is google.com or something, so there is something called DNS that we will study later. So you also need IP address of the DNS server. So these are just few details that you will be needing if you are just booting up your computer. Now there are a couple of options to get these details. Like, I mean, if you are just booting up your computer, then you can even manually enter these details. So one thing is that manual host configuration. This is one thing. Another thing is that you can use any of this protocol, which is RARP, BOOTP, or DHCP. Now let me just go to this manual host configuration. What does this mean? Okay, suppose you have your IP address. I mean, let's suppose that you know that this is the IP address that that will be assigned to you, or this is the IP address that you can use basically. Okay, suppose somehow you know this. Just a second. Yeah, so suppose somehow you know that this is the IP address that you can use. So you will be entering that IP address manually, and similarly you will be entering subnet masks. No. Is the concept okay? Let me just continue. So basically you will be entering the subnet mask default gateway. You will be entering these things manually, right? How to do it in Windows? If you have Windows system, then I'm sure that some of you might have already done it, that you can enter. So there is an option that obtain IP address automatically, or there is an option that says that enter your IP address or subnet mask, and then there is also one more window. I think this gateway that just asks you to enter the gateway address also. Okay, so I mean, these are the details that you can also fill manually. And if you have filled it sometime in your college time, in your BTech or something, maybe, right? Okay, I used to do it. So basically, I learned it as a hack in my BTech. So whenever I'm in library or something, sometimes the internet doesn't work. So at that time, I'm connected to my college internet library and in library internet and Wi-Fi, and the internet was not working. Let's suppose sometimes internet doesn't work. Then I learned this hack, and I used to ask the IP address of my any of the classmate, any of my friend, that okay, what is the IP address that is assigned to you? So I will just make the next IP address. So maybe it is assigned 239 is assigned to him or her. So I will say that okay, let me just see if 240 is working. Most of the time it works. So if internet doesn't work in library, I used to do this. Like I used to enter this 240. I mean, I used to enter some random IP address based on the IP address that my friend is having. Okay, and maybe just next or maybe next 2-3 IP addresses. Let's suppose I entered 240. Then what used to happen? Whoever has already 240, okay, either the 240 is assigned, or if the 240 is not assigned, then I mean, whoever has already 240. Sometimes I do not remember. Maybe that sometimes like I get the higher preference. Then I mean, my internet is working, and then whoever is already having 240, that person's internet get stopped sometimes. Okay. So anyway, like you can even enter manually these details. Maybe some of you have already done it. If you have not done it, you can even try it. Like this is just a 2-minute job. Okay, in Windows you can do this. In Linux also you can do this, but I do not have this screenshot with me. Okay, so you can enter these details manually, or maybe you can use these protocols, maybe RARP, BOOTP, or DHCP. So let's just go to these protocols, what are these and how they are helping us. Right. Okay. So first protocol is reverse ARP. It is just reverse as ARP. Why? Because what do ARP do? Do anyone remember? What does ARP do? ARP basically given the MAC address. Okay. Sorry. Given the IP address or the MAC address. Suppose that you are here. You want to send something to B, right? And this is this may be in the same network, maybe in another network, and you do not know the MAC address of B. So, but you know the IP address of B. So, given the IP address, right? I mean, given the IP, you get the MAC address using ARP, and given the MAC of your own, okay, not somewhere, not for some other host. Okay. MAC of your like given the MAC address of your own host, which means like let's suppose that you are A. So given your own address, your own MAC address, you want your own IP address. Okay, it's not like you are looking for someone else IP address. Okay, so here given the MAC address of your own, you want your own IP address. So that's why it is called reverse of ARP, RARP. This is just first protocol that we know. Okay. Yes. So MAC address is basically for every computer. It is hard design, which means like for every computer it is fixed. So MAC address is known to every computer by itself. I mean, you might not know the MAC address of someone else. Okay. A and B, these are the two computers. A knows its MAC address. B also knows its MAC address, right? MAC address, everyone knows its MAC address because that's the hard coded. It's in the chip. That is network interface card. It's in there, right? In NIC, it is already there. MAC address is already there, but you might not be knowing your IP address. So that's why what you need to do, you need to use either manual intervention, something like this, or maybe one of the protocol. And this reverse protocol is called RARP. NIC belongs to which layer? No, NIC doesn't belong to any layer. Like inside the NIC, there are layers. I mean, those layers which are application layers, transport layer, okay, transport layer, network layer. These are generally in your operating system. These are implemented generally in your operating system. The hardware part, which is data link layer. Okay, I think in one of the video, I think I have talked about it in one of the theory video. I do not remember exactly. In data link layer video, I think I have talked about it. So this data link layer is generally implemented in the NIC using the hardware. And that's why like we have I mean data link layer is the first layer that deal with the physical intervention. So basically that's why we have the media access control protocols in the data link layer only, because all other layers doesn't deal with the hardware. Only data link layer deal with the hardware directly, right? I mean, it could be any medium, could be Wi-Fi also, could be your physical medium also, which is LAN or something. But data link layer is the first layer that deals with the transmission of any packet directly. Okay, so given the MAC address of your own in RARP, you get your own IP address, right? Given MAC of your own, we get IP of, I mean, on you get IP of your own host, right? Something like this. So basically in RARP, you know the MAC address and you do not know the IP address. That's what the objective is. So what does this RARP do? RARP basically says, let me just read it out. Okay, the first question you might be thinking is this, that how a client can send an IP datagram when it knows neither its own IP address. Okay, so this is A, and there is one server, okay, which is RARP server. Using this, you are going to get your IP address. So basically, currently you know your MAC address. You do not know anything else, which means you do not know your IP address. Okay, you do not know this. You do not know this. You do not know even the RARP server IP address. Okay, you do not know its IP address also. Neither is MAC address or anything. You do not know. You only know your own MAC address. That's all. So now a natural question that can come to your mind, that how can a client send IP datagram when it knows neither its own IP address, or maybe do not need to be IP datagram. Just a second. Yeah. So sends a packet. Let's just call it packet for now. For other protocols, it could be IP datagram. I will talk about it a little later. I mean, for DHCP and BOOTP, it could be IP datagram, but for this, it is not IP datagram. For RARP, it is not IP datagram. I will tell you, like, what do I mean? So your question is that how can a client send a packet when it neither knows its own IP address, nor it knows server's IP address, the destination IP address? Then what is the answer? I mean, it doesn't know its own IP address, neither knows server's IP address. Then just like ARP, what it does, the client simply put all zeros in the source and all zeros in the destination. I mean, it just broadcast it, and it will say that I do not know anything. I mean, I do not know my IP, I do not know RARP server IP. So what it will do, it will say that, okay, let's suppose there is a channel in which many hosts are connected. This is A, this is B, and there will be RARP server also. Okay, in the same network, there has to be RARP server also. Now, what A will do? A knows its own MAC address. Now, what A will do? A will just broadcast a packet that is called RARP request, just like ARP request, RARP request. Okay. It will say that, see, I do not know the I do not know the IP address of me. Like, if there is a RARP server on the same network, then please provide me the IP address. That's the RARP request is saying. Now, just like ARP, if you remember ARP, there used to be the 4 fields, right? I mean, source IP, destination IP, target IP, destination IP, something like this, right? I mean, target MAC, destination MAC. So this ARP and RARP, this header, okay, the packet format looks exactly same, just little bit of difference. So I do not have the format here because it is not necessary, but yeah, they look exactly same. Now in RARP packet, I will be putting, if I do not know something, I will put 0. If I do not know something, then I will put 0 in that field, which means if I do not know my my IP address, I will put 0 there. If I do not know RARP MAC address, I will put 0 there. If I do not know RARP IP address, I will put 0 there. Only the thing that I can put is this one. Okay. Now tell me, how does this RARP server get to know that it is designed for me? Because it is a broadcast address and it do not even have the RARP IP address. You're getting my point? So here in this network, there are many hosts, right? Including this RARP server. So if A is broadcasting a packet which is having these fields, right? Which is having A MAC address, and then instead of A's IP, it is having 0. Instead of RARP MAC, maybe, okay, destination basically MAC address, it is having 0. Instead of RARP IP, it is having 0. So basically these fields are just 0, 0, 0, right? This is valid. So out of those 4 fields, only just one field is valid. Now tell me, how does this RARP server get to know that this is only designed for me? Any idea? Because this packet format is RARP, which means the packet field will be basically understood by only RARP server. So there is a particular header for every protocol, right? If you talk about IP protocol, there is a particular header. If you talk about ARP protocol, there is a particular header. Similarly, if you talk about RARP header, there is a particular RARP protocol, there is a particular header. That header can be understood by RARP server only. Okay. That's why the RARP server can only respond. Otherwise, not all the hosts can respond because they do not even have the MAC address of the A. Oh, sorry, IP address of A. So this is how A is requesting for its own IP address. Now, what will RARP server will do? It is having a static mapping between the MAC addresses and IP addresses. It will say that, okay, this is A's MAC, and then this is A's IP. This is RARP server static mapping at RARP server. Okay. Now it receives that, okay, if this is the A's MAC, then it will reply as an unicast address. Right? So it will reply A's IP. So that's how it is happening. Now let me go to this slide, which is telling you the exact operation. So it is saying my physical address is this. Now I'm looking for my IP address only. Static mapping means that there's a fixed mapping that, okay, in this network there could be at most these many hosts, and that's why, like, for every host, for if the MAC address is this, then this will be the IP address, something like this. Static means fixed mapping. Okay. Yeah, this is the protocol that no one is using, okay, because of many limitations that I will talk about. Let me know if there is any doubt till this point. Okay, so what is happening here? See, this is saying that my physical address is this, and I'm looking for the IP address, right? Now, this request is broadcast to everyone. It is going here, it is going here, it is going here, and it is going here. RARP request is broadcast. Now, once the server get this request, then this reply is unicast. Okay. So it is unicast using A's MAC address, right? So A, like this A is having its MAC address, and then RARP server can just unicast using its MAC address. Okay. Yeah. Now, okay, see, this is a broadcast, so maybe this destination IP could be just all broadcast address. Okay, so this is a destination IP. This will be the broadcast address. For MAC, the broadcast address is all F, all ones. Yes, each network has its own RARP server. Yes, that's very important. Okay, let me just write it here. That a few points about the RARP. First point is that RARP request is broadcast and RARP reply is unicast. Second point is that each network has its own RARP server. Right. Third point is that RARP mapping is static. RARP mapping is static. Okay. So actually, these are not just points, these are the limitations of RARP. Let's just see the limitations of RARP. I mean, the RARP is one protocol that almost absolute means no one is using now. Okay, it is almost absolute that no one is using this RARP. But yeah, it makes some sense to study this just for the sake of comparison with the other protocols. So as broadcasting is done at the data link layer, yeah. So one more point, let me write here. Okay. So the fourth point is that this packet, RARP packet, get encapsulated in Ethernet frame, just like ARP. Okay, so basically RARP packet get encapsulated just like ARP, which means in ARP, if you remember, I used to have the Ethernet frame and then I used to have the ARP packet here, right? Similarly, I have the RARP packet also just like this. So which means like I do have a broadcasting or everything at the data link layer only, which means like I use the MAC addresses to communicate in the RARP and in case of RARP also. Okay, so broadcasting is done at the data link layer. The physical broadcast address, all are ones in case of Ethernet, and do not pass the boundaries of the network. Obviously, it cannot pass the boundaries of the network, right? This means that if administration has a several network or the several subnets, it needs to assign a RARP server to each network or each subnet. So that's the limitation of RARP, that we need to have the RARP server at each network or each subnetwork. This is the reason that RARP is almost absolute. Okay, so there are few protocols which are BOOTP. I mean, two other protocols which are BOOTP and DHCP. In fact, BOOTP is also almost not usable. Like we are only using the DHCP that are replacing RARP. So let's just see the BOOTP also. Is everyone clear with this? So there is nothing much in RARP. This is very simple. I mean, you just broadcast the request and it is just unicasting the reply. And what are the limitations? You have to have RARP everywhere. And the second point is that there is a static mapping also, right? Now, one of the limitation, which is that you have to have RARP server everywhere, that got overcome using the BOOTP, but the static mapping is still there in the BOOTP. Let's just see this BOOTP now. So, okay, key RARP limitations. RARP is a user process, but works over a link layer directly. RARP server system dependent. Yeah. So basically, like our system dependent in the sense like which protocol you are using. Like at the data link layer also, you are having different protocols, right? Ethernet and maybe PPP or like this. So which protocol you are using, maybe based on that, I need to implement the RARP server also. I need to have that RARP server also. Yes, token ring is also one of them. I mean, these are some sophisticated protocol, token ring and all, and these are not in the GATE syllabus now. So needs to interface with the link layer driver directly, separate filters and direct access to the hardware needed. Okay, anyway, so returns only the IP address. Yeah, this is also very, very important point that let me write there only. That RARP, so I needed a few of the things, right? I needed few of the things, which are the IP address, subnet mask, and default gateway address. I needed these 3-4 things, but RARP only returns the IP address. Okay, what are the other things? How I get these other things? To get these other things, I use some other protocol. So RARP doesn't help me to get these things. I need to use some other protocol to get these things. So basically, RARP only returns the IP address. This is also something to note down. Okay. So fifth point is that returns only IP address and not subnet mask, default gateway, DNS address, these things. It doesn't tell me these things. So to get these things, we need to use another protocol. So that's why like no one is using the RARP. Okay. So these are not just points, you can also say limitations. Yeah, host need ICMP, TFTP to complete the booting, which means like we need these protocols to get the DNS server address, default gateway address, and these things. And RARP doesn't provide these things. It only returns the IP address. Can't relay RARP request to central server. Need RARP server per broadcast domain, right? That's what we have seen. Now let's just see another protocol, which is BOOTP protocol. A full form of this protocol is called bootstrap protocol. And why this BOOTP protocol? I mean, why this name is there? Because when you are booting up your protocol, when you are booting up your system, then this process is called bootstrap process, and that's why like it is helping us at the boot time. So that's why this is also called bootstrap protocol. Okay. So what piece of information a host needs to assign? See, these are the piece of information that we need. IP address, subnet mask, default gateway address, DNS address, like these are the things that we need. So BOOTP is there to help us out. And BOOTP is static, as I said earlier, that it is static in the sense that here also you have the fixed mapping, just like this. Like this is the edge MAC address and this is the edge IP address. Just like this in RARP, just like the RARP, BOOTP also have the fixed static mapping. So BOOTP is also static. When a client workstation asks for the above info, so suppose that I'm asking for the above info, then it is received from the fixed table. Okay. So there is no change, which means like every time the client asks for the info, it gets the same result because the mapping is static. Now let's see how it is working basically. Okay, this is just common points, which is it is an early alternative to RARP, which means like nowadays we are using DHCP, but yes, it was one of the alternative to RARP. Provide more than just one IP address, more than just an IP address. Okay, it also provides a few other information, which are these. Okay. Yeah. Obtain configuration parameters from the server. Obtain configuration parameter. from a server. So basically configuration parameters means these are called configuration parameters. Okay. So yeah, we obtain these configuration parameters from the server, and it is using UDP. So I will tell you about it. Okay. So anyway, let me just tell about this point, which is that how it is using UDP. See, this protocol is a client server based protocol, and it is working at the application layer. So if you remember RARP, it was working at the data link layer, right? I mean, there was a Ethernet frame. Hello. Okay, so I think yesterday I have not charged it, but anyway, like let's just charge it for 10-15 minutes and then it will work. So yeah, what I was saying, that this Ethernet packet, this UDP packet is get encapsulated. This BOOTP packet get encapsulated in the UDP packet, okay, and then this UDP packet get encapsulated in an IP packet, and this IP packet get encapsulated in this Ethernet or maybe some other protocol packet, right? So have you understood this? So this is different from RARP in the sense that RARP get directly encapsulated in Ethernet because it is working at this layer, and this BOOTP is working at application layer, and then it gets encapsulated in the UDP packet. Okay, and also DHCP. Okay, BOOTP or DHCP both are almost same. Just like ARP and RARP, just like this, BOOTP and DHCP also almost same. In fact, there is almost same packet format, same header format for the ARP and RARP. Similarly, there is exactly same for DHCP and BOOTP, just a one bit of difference. Okay, so the exactly same packet that we send just a one bit of difference in BOOTP and DHCP. Anyway, these details are not important, but I'm just telling you. So let's take two cases when the client and server both are in the same network, and case 2 when client and server both are in the different network. So in RARP, both has to be in the same network. Okay. In RARP, so see, if you remember the RARP, what used to happen in RARP, we used to have one server in one of the network. In each network, we used to have one server, right? So similarly here, like not similarly, like unlikely here, we can have this BOOTP server either in the same network or in the different network. So that's the benefit of BOOTP, which means that BOOTP server need not to be in the same network. So that's why there are two cases. Case 1, when the client and server both are in the same network, and client and server both are in the different network. Okay. See, this is the first case when this server and this client, this is a BOOTP client and this is a BOOTP server, both are in the same network. Then I can send just like a RARP thing, which means I can broadcast it, and then it will be replying as a unicast, right? Now, obviously the request will be the broadcast. So this is a broadcast request. But if both are in the different network, okay, if both are in the different network, then in this case, there is something called a relay agent. That relay agent will be present in the same network. So what is happening here? The server could be in the different network. Server is here, which is in a different network. But there are something called BOOTP relay agent. So BOOTP relay agent has to be there in your same network. So whenever you are broadcasting some request, okay, at that time, at that broadcast time, just a second. So the requests are broadcast, right? So whenever you are broadcasting a request, at that time, instead of server, this relay will be responsible to reply, which means this Okay, IoT I have not studied. So this relay term is in the IoT, right? I mean, that's what you're saying. So this relay server will be responsible for your reply. So what you will do, you do not know that whether the BOOTP server is in your network or in the different network. You will just broadcast normally. Now, if that's in the same network, it will reply. If that's not in the same network, then relay agent will be in your network. Then it will forward your packet. It will forward your packet to BOOTP server, and then BOOTP server will reply, and then the relay agent will reply to you. Something like this, right? So it will be having something like this, like whenever you're sending a packet, then you will be broadcasting, and then relay agent will be responsible. So let's just see this in more detail. Okay, so the case one is that this is the case one when the client and server both are in the same network. The BOOTP server can be on the same network as both BOOTP client or on the different networks, right? So this is the case one when both are in the same network. Okay. So now let's just see what they are saying. The BOOTP places this packet inside a UDP packet. Note that BOOTP is an application layer program, right? So what it will do, it will put this BOOTP server will put the packet inside the UDP packet. Okay, so there is a UDP packet. I mean, inside the UDP header, there is a BOOTP packet, and it will reply. Now let's see another case. This is the case 2, where the server is not in the same network, is in the different network, right? So when the client and server are on the different network, we need a relay agent, because client does not know the IP address of the server. So that's why we will be needing a relay agent, and a limited broadcast address gets dumped by the local router. So basically for broadcasting, then you cannot broadcast out of this router, right? Obviously, like this will get dumped by this router. You can only broadcast within only one network. You cannot broadcast over the internet. Suppose you want to broadcast within your own network, then what is the IP address you will be using? You will be using IP address. If I talk about, you will be using this one. Sorry, yeah, this one. If you are broadcasting within your own network, this is called limited broadcast address. If you want to broadcast out of your own network in some other network, then you will be using directed broadcast address, right? But in any of the case, you can broadcast in just one of the network. Okay, so you will be broadcasting your packet using the IP address, right? Like earlier we used to communicate using the MAC address only. That broadcast address and these addresses were just MAC address, but now we will be communicating using the IP addresses. So it will broadcast using the IP address, and then the relay agent will detect it. Relay agent will send the unicast address here, unicast request here to the BOOTP server. So I hope you understood. Let me just go over the theory again. So the case one is when both of the networks both of the client and server in the same network, right? So when BOOTP client is started, it has no IP address, so it broadcasts a message containing its MAC address onto the network, right? So it broadcasts a message containing its MAC address only. Now this message is called BOOTP request. So I think I might be having the diagram. Okay. So basically the first message that you are sending is BOOTP request, which is a broadcast message. Which reply to the client, which of the following information that clients need. So the client's IP address, subnet marks, and the default gateway address. This is what clients need, right? So its own IP address, subnet marks, default gateway, and DNS address also. Which reply to the client with the following information. So it will reply with this information. It will tell the IP address of the host name of the BOOTP server. So it can also tell the IP address of the BOOTP server also. Okay, so that next time it do not need to broadcast probably. Next time obviously it does not need to do anything because it has all of these things already. But yes, it tells the IP address and the host name of the BOOTP server, IP address and the server that has a boot image, which has a client nothing. Okay, so these are the few details which are important for the operating system. So what it is saying, the IP address of the server that has the boot image, which the client needs to load its operating system. So basically these this point is not useful for the host which are having their own disk. This is important for the host which are diskless, which do not even have their hard disk. Okay, diskless system. who doesn't even have their hard disk, so it do not have operating system or boot image with them, because they cannot restore the boot image with them. So basically it tells that, okay, to whom they should be asking for the operating system or for the boot image, right? So I mean, this point is not relevant for the systems which are having their own hard disk, right? Okay. So the second point is saying, when the client receives the information from the BOOTP server, it configures and initializes the TCP/IP protocol stack and then connects to the server on which the BOOTP image is shared. Right. I mean, the second point again, the connects to the server on which the BOOTP image is shared. It is not that much important for us. I mean, this is for the diskless server systems. Okay, which needs to know that where is their boot image. Now let's take the second case and let's see what are all the steps that we are doing. What is the second case? This is the second case, right? Where we are broadcasting here and then this will be unicasting. Let's see all set of steps that we have in the second case. First is that if server exists on the same distinct network, okay, the BOOTP request is broadcast because the client do not know the IP address of the server. So basically first it will broadcast the BOOTP request, and like anyway it will just broadcast the request. The client simply uses zeros in the source address and ones in the destination address, right? So it will be saying that once in the destination address means that it is a limited broadcast address, and zeros in the source address means I do not know my own address, right? It means I don't know my IP, right? So basically, this is what it means. I mean, zeros, if you're putting, it means that you do not know something. If once you're putting in the IP address, all ones, which means 255.255.255.255, it means that it is a limited broadcast address, right? Okay. But a broadcast IP datagram cannot pass through the router. To solve the problem, there is a need of intermediary, which is a relay agent. One of the hosts in a local network, a router can be configured to operate at the application layer, can be used as a relay agent. The host in this case is called relay agent. The relay agent knows the unicast address of the BOOTP server. So it is one agent that knows that where is the BOOTP server, right? So obviously, like it has to know. So someone has to know where is the BOOTP server. Otherwise, how I will be reaching to the BOOTP server. So this relay agent knows IP of BOOTP server. Right? Knows the unicast address of the BOOTP server. When it receives the type of the packet, it encapsulates the packet in a unicast datagram and send the request to the. So basically, it will just send the unicast request to the BOOTP server. The packet carrying a unicast destination address is routed by any router and reaches to the BOOTP server. So finally, your packet has been reached to the BOOTP server. Now let's see that how BOOTP server is behaving. So now your packet has reached to the BOOTP server. The BOOTP server knows the message comes from the relay agent because one of the field in the request defines the IP address of the relay agent. So basically, there will be a source IP. Using the source IP, BOOTP server will get to know, okay, this is the message sent by the relay agent. BOOTP server sends a BOOTP reply to the relay agent. Then it will send the reply to the relay agent, which means like it will say that, okay, this package has come from me, and then it will send the reply to relay agent only. It do not send the reply to the. I mean, it cannot even send the reply to the BOOTP client, or it can send. Yeah, it can send basically. Like that's not very hard requirement, but it sends to the relay agent. Can anyone tell me why? And first question is that why it can send directly to the host? Because it knows the IP address of the host, right? I mean this is who is providing the IP address of the host, right? That's why since it knows the IP address of the host, it can send directly to the host also, but it is sending to the relay agent. The reason being is that why it is sending to the relay agent? Because next time, let's suppose host is getting boot up or something, then now relay agent will be having the mapping, right? So relay agent can store the mapping. So that's why it will be stored in the it is sending to the relay agent. So the next time if that system wants IP address, then the relay agent itself can reply. Okay. BOOTP server sends a BOOTP reply to the relay agent, and the relay agent, after receiving the packet, sends to the BOOTP client. Let me know what are the routes. All the devices in all networks, only one BOOTP server is there. No, there could be multiple. I mean, there are multiple, obviously, because what if one fails? So there could be multiple. Okay. So I hope you understood. Now let's just see what are the limitations of BOOTP. I mean, why that BOOTP is also not very much popular. So can you think of any limitation? Maybe one of the limitation is that it is having the static mapping, right? I mean, it is also having the static mapping. Let me write here. So here also it is fixed. Like, okay, this is the age MAC address. Then what should be the age IP? And why it is a limitation? Because let's suppose that let's suppose there are 100 computers, right? And only one of them is active. So let's suppose that there are 100 computers, 100 hosts, and you have a table that is having the 100 entities with the 100 IP addresses. Now let's suppose out of these 100 only one is active, right? Now there is another computer which is, let's suppose, 101 host, okay, that wants to connect to the internet. Since you cannot, it has its MAC address. Since you cannot provide any IP to this host, so you will say that currently you cannot get connected, right? Because you do not have any IP to this host. So obviously it's not a good idea. I mean, if there, in this 100 only one is active, so 99 addresses are getting wasted. And if someone wants to connect to the internet, you will say that, see, you cannot connect because I do not have your IP address. For that, I need to take one IP address, then I need to assign your IP address to them. And maybe based on the number of IP addresses that you have in your network, based on that you will take a call. Should I waste one more IP address or not? So basically, it is not a good thing. Like ideally, what should be happening, that I should not be having static mapping. So whenever someone asks me IP address, I should be having a pool. In that pool, I should be able to assign some IP address, right? And that's where DHCP comes into the picture. So let's see the limitations. BOOTP is not a dynamic configuration protocol. Yes, that's the one of the most major limitation of the BOOTP, that it is not a dynamic protocol, right? Is this okay to everyone? Okay. Now the second point is that when a client requests IP address, the BOOTP server consults a table. Okay. My video is on, right? Okay. So when a client requests IP address, the BOOTP server consults the table and matches the physical address of client. Yes. So yeah, that is okay. That's a static mapping only. This implies a binding between the physical address and the IP address client already exists. The binding is predetermined, that is static, right? So here the binding or the mapping is static. However, if the host move to the physical network to another, yeah. So one example that I told you, that what is the disadvantage of binding this static mapping is that if some other host wants to come, then it is not feasible. I mean, it is not very easy to assign the IP address. This is one drawback. Another drawback is that, let's suppose you are in this network currently. Now you move out of this network to another network. Now here in this another network, like whatever the BOOTP server that you have for this another network, right? Suppose this BOOTP server doesn't have any mapping for your MAC address, then you cannot get connect to the internet if you are moving from one internet to one network to another network, right? So what if the host moves from one physical network to another? What if a host wants a temporary IP address only just for maybe for 3 days or maybe for 1 hour? It just need to work with the internet, and then it will not even not get connected to internet ever, right? So if I just want a temporary IP address, then I will be just having a static mapping, and for this static mapping it is forever, right? It will say, okay, for age it is the IP address. So that doesn't sound very good. If I just want for maybe 1 hour, I do not want for even like I don't want for forever, right? I don't want for 50 years. I just want for 1 hour. But if I just want for 1 hour, this BOOTP is saying take an IP address for 50 years only. Okay, I cannot give you for 1 hour because it is static. Once it is fixed, then it is fixed. So that's the problem. The temporary IP addresses are not allowed. BOOTP cannot handle the situations because the binding between the physical and the IP address is static and fixed in table until changed by the administrator. So these situations cannot be handled by BOOTP. BOOTP is static. So anyway, the only drawback that BOOTP is having is static. And because of the static thing, there are actually many things that we cannot do. What are those things? Maybe temporary IP address, maybe relocation, maybe some new host want to connect, right? which means let's suppose this host want to connect, something like this. So basically we do not have because of the static, we do not have these facilities in the BOOTP. The only drawback for the BOOTP is it is static, right? Now let's move to another protocol, which is dynamic protocol. Okay, DHCP. So basically before DHCP we have seen the RARP and BOOTP. RARP was having the two drawbacks mainly. What was those two drawbacks? RARP server in each network. Another one is static mapping. Now, one of the drawback has been resolved by BOOTP, and only drawback that is remaining, it is static mapping. Now we are going to resolve this drawback also, and then we will be having DHCP. Okay. Okay. So BOOTP is not dynamic, and now let's see the DHCP server or DHCP protocol. So DHCP stands for the Dynamic Host Configuration Protocol that provides the static and dynamic address allocation that can be manual or automatic. So it also provides the static in the sense that if you want the static mapping, then it can provide the static mapping. So basically static mapping are for the big servers which are always on. Okay. So some big servers which are always on, then I will say that, okay, for this server, if this is a MAC address, then this is the IP address. I mean, for the systems which are always on, and generally the IP address doesn't change. For those kind of systems, for those kind of servers, I provide, like DHCP provide the static mapping, but mostly it provides the dynamic mapping for the usual host, for the daily usage computers. It provides the dynamic mapping. How? Let's just see. So BOOTP is static, but DHCP is dynamic and can also be static if you want to, right? It is just, it provides both of the things. DHCP has a pool of available addresses. When a request arrives, DHCP pulls out the next available address and assign it to client for the negotiable time period. So basically, it says that, okay, maybe for the 10 minutes, I'm giving you this IP. 10 minutes. Let's suppose there is some time period for which it will say that, okay, for 10 minutes, I'm giving this IP. Something like this. If host wants the IP for longer, then it can renew the IP address maybe after 5 minutes, 6 minutes. Okay, something like this. So basically, just for some time, okay, just for some time, it gives the IP address to the some host, and then if host wants to renew, it can definitely renew. So when a request comes from a client, let's suppose a client wants to know the IP address, then what it will do? The DHCP server first consult the static table. Okay. If there's a client, and then it will check whether this client is a superior priority, which means the client is a high-end server maybe. Okay, then it has to first check with the static table, because in the static table I am having the static mapping that, okay, for this server I will just give this IP always, something like this, right? So if they're high-end servers, then I will just check the static table first. If there is nothing in the static table, then I will just assign any of the random IP address. So DHCP is great when devices and IP addresses can change. DHCP packet format is almost identical to BOOTP packet format in order to be compatible to BOOTP. In fact, there is just one bit of difference. Okay, sorry. Here it is written, only difference in just one bit flag. There is a flag. I do not have that packet with me, but in that packet there is a flag. Okay, that is either, if it is 1, then it is BOOTP. If it is 0, then it is DHCP, something like this, or maybe vice versa. I do not remember the configuration also. Maybe for 0 it is BOOTP, for 1 it is DHCP, something like that. It is just a difference in just one bit of flag. Okay, so if it is static, then what does this mean? The static address allocation in the in this capacity, DHCP act just like the BOOTP. Okay, there is no difference in DHCP and BOOTP. If DHCP is providing the static allocation, it is backward compatible to the BOOTP. Backward compatible means if you're upgrading some software, then let's suppose that this system is using BOOTP. Okay, it is sending the BOOTP packet, which means like I'm the host, and I'm sending the BOOTP packet. And then this is a server which is a DHCP server. Then it can also handle these BOOTP requests. That's called backward compatibility. That whatever you had earlier, you do not make it completely useless. You can still work with that, and you are having the advanced facility also. Which means if someone is sending BOOTP request to you, even though you are the DHCP server, you can still respond to that. That's called backward compatible. That whatever is the old, I can also work with the old. Although I am the new, but I can also work with the old. Okay. Yeah. So which means a host running a BOOTP client can request a static address from the DHCP server. Yes, that is written here also. That if the host is on the running the BOOTP protocol, then it can get the response from the DHCP server. A DHCP has a database that statically binds the physical address to the IP address. Okay. Now let's see the most widely popular use of the DHCP, which is the dynamic allocation. So let's see that how it is dynamically allocating, right? Okay. Let me know if there is any doubt at this point. Meanwhile, let me connect to the mic. I think. Okay. Yeah. Can you hear me now? Is there any difference in audio that you were getting earlier and now? Or this is same? So now let's just see that how it is dynamically allocating, right? Because that's the whole purpose of DHCP. Okay, this is better. Now DHCP has a second database with a pool of available IP addresses. So in this DHCP, you have the pool of IP addresses available. Right? The second database, DHCP dynamic, like let's call it DHCP dynamic. When a DHCP client requests a temporary IP address, the DHCP server goes to the pool of available or unused IP addresses and assign one of the IP address for the negotiable period of time. Which means it might give it for 10 minutes, then it can negotiate for more time if the host wants for the more time, right? That's perfectly fine. Now, when a DHCP client sends a DHCP request to the DHCP server, right? So client will send the request to the server. Now the server first check it's the static database. If the entry is not there, then it will give from the pool of the available IP, right? Okay. The DHCP aspect of the dynamic aspect of the DHCP is needed when a host moves from network to another network. So host, like all of these problems, like if it is needed a temporary IP addresses or maybe relocation, maybe this host wants some address and there are 100 hosts that were having the static mapping, then I'm just wasting 100 IP addresses. Let's suppose that these are not in the use, but here it's not the case, right? I mean, if there are 100 hosts, if they're not using IP address, then I do not need to worry about it because I have assigned IP address to them not permanently, just for some period of time, maybe for 10 minutes, right? So that's why I will be having always this available pool of IP addresses with me. Yeah, temporary IP address is allowed here. This is not a problem. Issue is leash for the specific time, right? Yeah, this is important. The DHCP server issues a leash for a specific time. When a lease expires, the client must either stop using the IP address or renew the lease. So basically, even before the lease expires, the client will ask for the renew if it wants to use the IP address, right? So it issues a leash for the specific time only. The server has an option to agree or disagree with the renewal. Okay, so maybe if let's suppose the host wants to renew, the server may say that okay, currently I do not assign the IP address, so it may agree or disagree to the renewal. If the server disagrees, the client will stop using that address. Okay. Now let's just see that how DHCP is actually communicating. So I mean, how it is having the communication between DHCP client and DHCP server. So these are the few packets that we send the client and server. These are the few packets in the DHCP. Let's just see how it is happening. So there are 4 packets, and this is the diagram. Maybe I can copy the diagram at that page only. Okay, let's just see that what is written here. So what we are saying, a DHCP client sends a broadcast packet that is called DHCP server to DHCP server on the LAN segment. So basically, in this client and server case, let's suppose this is client, this is server. In this case, there is something called passive open. Okay, so server is always passive open. What do I mean by passive open? Basically, let's suppose you have two code. Okay, I mean, let's suppose just to simulate, you have written two code. One is client.c and one is server.c. Client.c. Let's suppose another is server.c. Now, if you want to communicate, let's suppose you want to send some data from client.c to server.c and server wants to respond or something like that, right? Let's suppose there is some mechanism that you want to simulate on your own computer only. Okay, just for the simulation purpose. Then tell me, will you run this client.c first or server.c first? You like, and you are having terminal. In your terminal, like let's suppose you have opened two windows. Okay, terminal, two windows of the terminal. One to run for the client.c and one to run for the server.c. Tell me which one you will be running first, client.c or server.c? Generally, first client will send something, will ask something, or like first server. Any guesses? Yeah. So Mahabhat is saying client. Actually, the answer is server. Can you guess why? Because if you are not even running server.c, okay, then the server is not even active. If client is sending something, then there will be error. It will say the server is dead, right? If you are running the client.c, let's suppose GCC space client.c, if you're running directly without running the server.c, it will give the reply server is dead, because it will just say fraction of second to run any normal program, right? Server is dead, something like this. Yes, it is similar to the client server programming. So basically, always we are going to run the server.c first, because we need to make the server active. That's called passive open. Now server is ready to listen. So always run the server.c first, so that server get active. Now client can request anything, right? Generally that's the case. Yes, to know the existence of server. So basically we need to run the server.c first always. That's called passive open, right? Passive open means that you are just waiting for something. You have just started. Now you are waiting for something. Okay. So I hope that is clear to everyone. Then what does this passive open mean? Now client can send the data. If server is not passive open, then if client sends the data, then will server be able to listen? Obviously no, right? There is server is dead. Then how server will be able to listen? So first server will behave like it is a passive open, and then the client will be sending some data, right? I hope that's fine to everyone. Now, let's just see that how it is happening in case of DHCP. So DHCP client sends a broadcast message, okay, which is called DHCP discover. It is just a name. It is a broadcast message to discover the DHCP server on the LAN segment. So just like a BOOTP, it will just broadcast, right? Broadcast. First message is broadcast. DHCP server, when it receives with the DHCP offer packet offering the IP addressing information, so it will reply. Okay, reply, it is request. Request is broadcast, just like every other protocol, and reply is unicast, just like every other protocol. Here we just have a specific name. This request is name as DHCP discover. If you want, you can just remember it. Otherwise, there is no need to remember. I'm just telling you because that's given in the textbooks. This is called DHCP offer. That's all. Okay. DHCP offer means, like, if you are replying, then you are offering some IP address with the DHCP offer packet. Now, if the client receives the DHCP offer packet from the multiple, so it may so happen that client is sending some DHCP discover. There could be multiple DHCP servers in the same network. Then multiple can offer, right? So it's not like only one can offer. There could be multiple. If client is sending, let's suppose this is client. And then if there are multiple DHCP servers, this is DHCP server 1. Then it can also offer, okay? They both are offering. It is now up to the client to whom it wants to accept the offer, okay? So now client receives the DHCP. If the client receives the DHCP offer from multiple DHCP server, the first DHCP server packet is accepted. So since it is up to the client, but generally like there is no point in, I mean, we do not know how to discriminate. So we will just accepting the first DHCP packet, maybe because like since it is the first one, maybe that server is nearer to me, right? Physically it might be nearer to me, so I will be accepting, maybe let's suppose this one. Okay, I mean it is just up to the client. The client responds with broadcasting DHCP request packet, requesting network parameter from a single server. So now the client responds by broadcasting DHCP request packet. Why it has to broadcast? Can anyone tell me? See, what is happening here? The client sends a packet. Now there are multiple servers. Okay, multiple are replying. Client is, let's suppose, accepting just this one. Okay, suppose the client is accepting this one only. If multiple are replying, client is saying that okay, I'm accepting this one. So this is request, which is broadcast. This is reply, which is unicast. Now client will basically now again broadcast something. Can anyone tell me why the client again has to broadcast something? See here, the client receives the DHCP offer, and it will receive the first. The client responds by broadcasting DHCP request packet, requesting a network parameter from the single server. Yes. So basically it has to tell to the other servers also that I have accepted one of the offer. Now you please do not wait for me. Okay. So it is broadcast to tell other servers. So basically in this offer, in this reply packet, actually this DHCP server has not told the IP address. It is just saying that I can offer. It is just saying that I can offer. Okay. So see here what is happening. This is the final diagram. Client is saying that I need IP address. And this is DHCP server 1. Maybe there could be multiple DHCP servers. This is DHCP server 2. Okay. And maybe there could be multiple. This is DHCP 3. Now let's suppose that this is offering you, this is offering you, and this is also offering you. They are saying I can offer. They are currently not giving you the IP address. They are just saying I can offer. Right? Now when it receives, it will say that okay, let's suppose it is receiving, it is accepting this one. Okay. Now it will say that okay, broadcast. It will say that now please tell me IP address. Right? That's what it will say. I hope you understood, right? So the fourth one, now DHCP will actually acknowledge it. The DHCP will just send the IP address. Now fourth one will be this. Then DHCP this server will just actually send the IP address now. Right? This will send. So there are 4 packets. Let me even number them. This is first one. This is second one. This is third one. This is the fourth one. So first is saying I need IP address. Second one is saying I can offer. Third is saying okay, I have accepted your offer. Now please tell me IP. Then fourth one is giving the IP. Okay, I hope you understood this. So this is called DHCP discover, then DHCP offer, then DHCP request. These are just names. Okay, I mean, there's no need to remember these names actually, to be honest. So that's the same diagram that I have here. Now I'm saying that okay, this is just passive open, as I just told you, right? Passive open means this server is open to listen something. That's called passive open. Now client will say I need something. It will DHCP offer, and these things have happened. Now when the that request is about to expire, the lease is about to expire, then it can again send the DHCP request again. Okay, so it do not need to send these packets that who can offer. Obviously now it knows that to whom I should be requesting. So now it can directly send the request to the designated server only. So when the lease time is about to expire, it can send again the request that I need the IP address for more time. So maybe it is sending request here. If the request do not respond, then the request is repeated. Maybe it can request it can again request if the server is not replying. Then maybe server can say that okay, if the server responds to the ACK, the client has a new lease. If the server can also respond with the negative acknowledgement, okay, then client must start over again. So it can say that I cannot assign you the IP address again. Then it will just say that, okay, now let me just ask everyone again. Okay, so these are the small details. You can just read it out later also. I mean, just very simple. Yeah, it is. I mean, you should be knowing that how the protocols are working, right? So there is like, I mean, I can just explain you that how it is working, but at the end, like, we should be having some memorization that, okay, this is working how that much. I mean, that's not very difficult, to be honest. That's very intuitive also. I mean, in DHCP, like what is happening and all. So it is very intuitive also. It's not too much to remember. Okay. So DHCP scheme of functioning. So yeah, these are the things that we have already discussed. I think DHCP, who can give me the IP address? This is the first question that DHCP asks. Then each node of the subnet receive the frame of the question, and then one of, I mean, all of them who can assign, they will reply. The client will respond to one of them, and I mean, it will broadcast, and then whatever client choose, that server will be replying with the IP address. So that's how it is happening. Now let's solve this question. What this question is saying. Let's see. So what they are saying is that, what are the IP addresses and source addresses of DHCP discover message? What is the DHCP discover message? The first message, right? First message, DHCP discover message. They are saying, what are the IP destination, source address of the DHCP offer message? Okay, so let's just solve the first question. IP destination and the source source address. So basically, source and destination IP. What are these? Yes, DHCP also have the relay agent. Okay, so yeah, DHCP. So all the limitations have been recovered in the DHCP. So now tell me, if you are sending the first packet, which is DHCP discover, what is your source IP? Since you do not know the source IP, so let me just call it ABC. For the A, the answer is, since you do not know the source IP, what you should be putting? And the destination IP, since you are broadcasting, it will be 255.255.255. Since you do not know, that's why it is 0.0.0. Right? It is saying I do not know. It is saying that it is a broadcast. Okay. Now let's just go to the second question. What are the IP destination and the source destination of the DHCP offer message? What are the offer message? The second packet, which is say that I can offer you. So in that case, what are the IP destination and the source source address? IP destination is, yeah, the same thing. Source IP and destination IP. If someone is saying I can offer you, at that time, has they offered you actually? Okay, this is interesting, right? I mean, that message, if you remember, the DHCP offer is unicast message, right? This is DHCP offer. Okay, so okay, so here this DHCP offer is also a broadcast message. Okay, sorry. So yes, this is also a broadcast message. This message. This I need IP. This is a broadcast message. Then again, this is also a broadcast message. Okay, all of these three messages are broadcast. Only this message is unicast. Yeah, sorry about it. So basically, this is a broadcast message that is saying I need IP. So this is a broadcast. And now, like, since I have not till assigned the IP address, so that's why this is also a broadcast message. Okay, because till now I have not assigned the IP address. Now this will be a unicast. Sorry, this will be also a broadcast message that will tell you, okay, I have accepted this offer, and then this will be a, okay, now tell me, this will be unicast or broadcast again at the last. If it is unicast, if it is unicast, then how can the client get to know that it is, because client do not know its own IP address currently, right? See, if client knows its own IP address, then I can send the unicast message using the IP address. I can say that, okay, the client will recognize that this message is for me. But client, as of now, client does not know its own IP address. So in that case, I mean, if I go to this question, what are the 3 values in the DHCP offer message? So this is DHCP ACK message, DHCP request. Yeah. So whenever you're offering, you will be putting the IP address of the client, network address, and these things, IP address, lease time, these things. Now tell me, what about the last packet? This last packet, will it be a broadcast or unicast? Which is the DHCP ACK. It will be sending to the relay agent only. I mean, it makes sense also, because okay, because in future maybe the relay agent knows that what are the available IP that is has, right? Okay, but the problem is that, yes, that's a good question. If it is sending to the relay agent, then the problem is that if it is DHCP server is assigning that IP to someone else, then the relay agent should also be notified, right? Okay, maybe it will be sending to the relay agent or to the host. Let me just think about it. See, the host doesn't know it's, I mean, it cannot send to the relay to the host directly, I think, because it's in another network. It doesn't know the IP address of the host, right? It's like if DHCP server is in another network, then it doesn't know the IP address of the host, then it has to send to the relay agent only. Now, in this case, if it is even the same network, let's suppose it is sending some directly sending some IP address, then should it be can it send the unicast? That's my question, because I'm using the IP addresses to communicate here. I think it should also be the broadcast. Most probably it should also be the broadcast, because I'm using the IP addresses to communicate, and till now I have not given the IP address to this client. So I think this should also be the broadcast. All the message should be the broadcast message. I will just confirm it in the next class, but according to me, it should be the broadcast, because till now I have not given any IP address to the client. So using the IP address, I cannot unicast anything for now. Later I can unicast if this is having some IP, but till now it doesn't have any IP. So that's why all of these messages has to be the broadcast message only. Okay, because I'm communicating using the IP address, not using the MAC address or something. It is broadcast within the same network. Okay, it is broadcast to the network where this client is residing. If DHCP, this is the client, and this is DHCP server. Both are in the same network. Okay, suppose both are in the same network, then what will this DHCP server will do? It will broadcast in the same network, right? I mean, all the messages are broadcast, so it will also broadcast last message, which is DHCP ACK. I mean, the name is DHCP ACK. Okay, all the messages are broadcast. Now, suppose if this is another network, okay, let's suppose that this DHCP server, okay, let me remove this completely. Let's suppose this DHCP server is in another network. Which means there is a client. Now there is a relay agent, but I am in the another network. Okay, suppose I am in this network. This is the DHCP server. Now what this DHCP server will do? This is a relay agent. Relay agent will send the unicast to this one DHCP server, and then it will be sending the unicast to relay agent. Okay, these will be the unicast message. Now this will again broadcast. So all the message will be just broadcast. only the messages between the relay agent and the DHCP server will be the unicast messages, right? Because the IP address of the relay agent is known, IP address of the DHCP server is known, so that's why I can send the unicast messages. But from the relay agent, I will be just sending the broadcast message. Okay, so I hope that is fine. Now, let's just move to another question. I think DHCP, what is your question? DHCP server send direct broadcast address to the network where the relay agent is there. I'm not getting. DHCP server, what it does? It will be a unicast communication. What is your question? What does this packet contains? Is this your question? What does this DHCP acknowledgement, the last packet contains? Yeah, this contains few of the things. I mean, IP address and these things, right? This contains IP address of the client, network mask, IP address, like for how much time I'm giving the IP address, something like that. Maybe more things also. They have just asked what are the 3 values. Okay, they have just asked for 3 values. That's why there are just 3 values. But yeah, there will be a DNS address. There will be a default gateway address, something like this. Network mask, right? Yeah, network mask is already there. So there will be multiple things. Okay. So this is one question where like if you want, you can attempt this question as an homework. I have the answer on the next page. So basically this question is little nice question in the sense that you will get to know the whole working, that how it is happening, everything, right? I mean, when your laptop is starting, and then what is the first hope to whom you are sending, and what, let's suppose you want to connect to the Wikipedia. So how, like which of the packet the Wikipedia response and all. So this is basically related to DHCP, ARP. DNS and TCP we have not studied, so you can leave these 2 questions if you want. But yeah, at least the DHCP and ARP, you just do it as an homework. The answer is on the next slide. So this is the answer. Okay. Yes, this is the same process. When our system is boot up, then this is the same process. If you the first time you connect to the internet, then this is the same process that is happening. And in most of the cases, actually, those addresses, like these addresses that we have, network mask, IP address, and these things, generally these are, if you are again and again connecting to the same network, then generally these things are remembered. I mean, since you have the hard disk with your own, that's why like your computer can remember these things. Most of the time, it can remember these things, right? So, and then the network mask and these things at least it can remember. Then obviously, like in modern applications, there must be some optimizations that I'm not aware of, but it should be the almost same thing. Okay, few of the things you can remember. And if you're connecting to the entirely new different network, then yes, those parameters will not work. I mean, you have to again start from the beginning. That's why if you notice, then initially, like when you connect to some new network, then it takes some time. I mean, 2-3 seconds, maybe like a fraction of seconds just to connect to some network, right? But if you're connecting to the old network that it is used to connect, then because most of the parameters are known, that's why it doesn't take that much time. Okay. So these are some easy questions. You can try these questions maybe, right? Yeah, so answer these are 1-2 questions that I have. So answers are here. Like this question is having the answer itself, which is the highlighted one. Okay, so these are 2-3 some small questions that I have taken from some PDF. You can just read out those PDF, read out those questions. These are just easy questions. If you want, I can just explain in the next class. Okay, if there is any problem. So yes, so that is the working of DHCP, BOOTP, and RARP. Now, surprisingly, I have not found any of the question from the previous year gate. Maybe they have not asked anything, or maybe I just overlooked. I don't know what is the case. Most probably they have not asked much of the question from DHCP or these things. I have searched the gate overflow PDF. I have not found any question from DHCP or RARP or BOOTP. Okay, so maybe they have not asked anything till now. But yeah, it is still good to know these protocols because they may ask anytime, like if they have not asked yet. Okay, just one question I have found in ISRO, which is saying that which network protocol allows the host to dynamically get a unique IP when you boot up. So dynamically, obviously the DHCP does, right? So A is the answer. So this is the only question that I found. Maybe if there is any question that you are not able to solve, you can ask me. I have not found any question from the gate PBQs. Okay. So thank you everyone. I think this is the time for DBMS class. So we will be starting in the morning, right? With another topic. Now the topic for the morning will be, I think it should be ICMP, IGMP, these protocols that we are remaining, and the NAT is one system that we have, network address translation. So these 2-3 small topics that we will be doing tomorrow. And then we will be starting with the TCP, maybe tomorrow, maybe day after tomorrow. Okay. Okay. Yes, we will be covering those protocols. Maybe after TCP, okay, maybe before TCP I will cover. Okay. This Ethernet and bridge protocol, spanning tree protocol, these things I will cover. Maybe before TCP I will be covering. Don't worry. Okay. Okay. Thank you everyone. Take care. Bye bye. If there is any topic that you feel that that should be covered, you can just tell me. You can just message in the Telegram, or you can just message here. Okay. Thank you. Take care. Bye bye.